Hello, today I will be talking about NLP in general, starting from low-level NLP approaches, then going over high-level NLP tasks, all the way to modern state-of-the-art NLP models such as GPT-3. I will introduce the new Azure OpenAI Service and perform a demo on how we can use the new GPT-3 based Codex models within VS Code to help us with coding. Let's start with low-level computational NLP approaches. So, the first step is tokenization. Tokenization is the first step in pretty much any NLP pipeline. It has an important effect on the rest of your pipeline. A tokenizer breaks unstructured data and natural language text into chunks of information. NLTK is an open source library for natural language processing. It can deal with basic low-level NLP tasks, including tokenization. It also comes with a set of text processing libraries for classification, tokenization, stemming, and tagging. It's pretty much the first tool any NLP student learns. Tokenization is an active research topic, believe it or not, although it really looks quite simple. Here in the given example, we have this sentence as the input, and we get a list of words contained in that sentence, or tokens contained in that sentence. Simple as that. But what if the language doesn't use space for segmentation? For a language like Chinese, which doesn't use spaces for word separation, this tokenizer will fail completely. So now let's take a look at text normalization. In a typical text normalization task, we remove all special characters, Unicode characters, emojis, URLs, Twitter handles, and so on. We make all capital letters small case, and we remove stop words. Stop words are the most common words in any natural language. For the purpose of analyzing text data and building NLP models, these stop words might not add much value to the meaning of the document. Generally, the most common words used in a text are in English, the, is, in, for, where, to, etc. Stop words play an important role in problems like sentiment analysis, question answering systems. That's why removing stop words can potentially affect our model's accuracy drastically. We can remove stop words while performing the following tasks: text classification, spam filtering, language classification, genre classification, caption generation, auto tag generation. And we need to avoid stop word removal when doing machine translation, language modeling, text summarization, or question answering. Next step, stemming. Stemming is the process of finding the root of words. Here, if you look at these words, they are all derived from the word consult, and consult, consultant, consulting, and so on can all be mapped to consult. Life is not easy. There are more complex scenarios, exceptions. Corpora is actually the plural of corpus. Better is actually good if you look at its stem, if you look at its root. So stemming is not going to find all of these cases. You need to use lemmatisation. Lemmatisation is the process of finding the form of the related word in the dictionary. The aim of lemmatisation, like stemming, is to reduce inflectional forms to a common base form. As opposed to stemming, lemmatisation does not simply chop off inflections. Instead, it uses knowledge bases to get the correct base forms of words. We can say that stemming is a quick and dirty method of chopping words to its root form, while on the other hand, lemmatisation is an intelligent operation that uses dictionaries which are created by in-depth linguistic knowledge. Hence, lemmatisation in general helps with forming better features for any subsequent language analysis. Part of speech tagging, POS-tag, is the labeling of given words in a text according to their word types, namely whether they are nouns, adjectives, adverbs, verbs, and so on. If you look at this sentence, at the very top level, we have S, the main sentence, and it consists of multiple phrases such as NP, which stands for noun phrase. Part of speech tagging can assist us in translation tasks from one language to another. Also, it can improve spell checkers all the way to grammar correction. But part of speech tagging can also be useful in word sense disambiguation too. WSD is one of the important challenges of NLP. Depending on their contexts, words can have different meanings. Take the word book, for example. In all of these sentences that you are seeing, the word book means something else. There are two main techniques that can be used for word sense disambiguation: knowledge-based, or sometimes called dictionary approach, and supervised approach. The first one tries to infer meaning by observing the dictionary definitions of ambiguous terms, while the latter is based on natural language processing algorithms that learn from training data. In either case, part of speech tagging will help with WSD. Okay, so far we looked at some basic low-level NLP operations. These can be handled by Spark NLP, which is already available on Azure HD Insight, should you do any NLP from scratch. So far, I have talked about tokenizing, stemming, lemmatizing sentences, and finding part of speech tags. Term frequencies are quite important in document classification problems after removal of stop words. Once you remove stop words, if the words, let's say bracket, court, player, Wimbledon, are mentioned frequently together in a document, we can easily deduce that someone is actually talking about tennis, right? So term frequencies and entropy calculations subsequently help you with topic categorization if you were to do machine learning to do topic categorization. Edit distance or cutoff distance, or sometimes it's called error tolerant finite state recognizers. I did one actually back in year 2001, and they are used by spell checkers to calculate the distance between two words before making a suggestion to the user. N-grams, they are quite important. In the computational linguistics and probability fields, an n-gram is a continuous sequence of n terms from a given sample of text or speech. The items can be phonemes, syllables, letters, or words, depending on the application. N-grams typically are collected from a text or speech corpus, and they become monograms if n is 1, bigrams if n is 2, or trigram if n is 3. Natural language processing is a trigram, natural language is a bigram, and language is a monogram, for instance. So, these are a few of the high-level NLP capabilities that can be solved by our Cognitive APIs on Azure. So there is a service for that. You don't need to write NLP from scratch. Another key NLP capability that can be solved by out-of-the-box services is detection of PII fields. You give it a text and it returns a JSON load that contains all these information, right? And named entity recognition is one of the most popular tasks in semantic analysis, and it involves extracting entities from within a text. Entities can be names, places, organizations, email addresses, and more. Relationship extraction, another subtask of NLP, goes one step further and finds relationships between two nouns. For example, in the phrase, Mutlu lives in Cambridge, a person, me, is related to a place, Cambridge by the semantic category lives in. This NLP capability, Text Analytics for Health, enables developers to process and extract insights from unstructured medical data. It is trained on a diverse range of medical data covering various formats of clinical notes, clinical trials protocols, and more. So this slide and the next one are a bit technical, so please bear with me while I try to explain. I'll try to do my best. LSTMs stand for long short-term memory. They are a type of neural network. The LSTM became popular due to its learning capability for long-term sequences. In NLP tasks, an LSTM can learn the word sequences in the sentence. LSTM network sequentially takes input, and this helps it to preserve the word order in a sentence. So in the given architecture, we have this encoder and decoder. The encoder deals with, in this translation case, from English to French, the encoder deals with representing how are you, okay, and then it encodes it, and the decoder takes that entity and decodes it into comme allez-vous, or however you would pronounce it properly in French. So the idea here is words are passed in sequentially and are generated sequentially. As a result, it can take a significant number of time steps for the neural network to learn. And they are not really the best way of capturing the true meaning of words. Even bidirectional LSTMs are not, because even with bidirectional architectures, they are technically learning left to right and right to left context separately. So what's the alternative? Transformer architecture addresses some of the drawbacks of LSTM. They are faster, as words can be processed simultaneously in parallel. The context of words is better learned as they can learn context from both directions simultaneously. This architecture was first showcased in Attention is All You Need paper by Google Research, written in 2017, only a few years ago, and it changed the field massively. The complete architecture can be split into two parts. There is an encoder and a decoder. In the image you are seeing, the structure on the left is encoder and on the right is decoder. It gives more attention in the computation to certain words than others, given an engram based on prior knowledge. Unlike LSTM, sequences can be processed in parallel, we said, not sequentially. Why? Because their positional encodings are also given as input. So you give the word as well as its relative position in the sentence compared to other words. So transformers are much faster than LSTMs because of this. What makes transformer actually conceptually stronger than LSTM is that we can physically see a separation in tasks. The encoder learns what's English, what's its grammar, what is context, and decoder learns how do English words relate to French words. The famous BERT language model stacks the encoder part of the transformer as its building block. Meanwhile, OpenAI's GPT uses the decoder part of the transformer as its building block. I appreciate this slide might be too technical, but to sum up, BERT is a stacked transformers encoder model. It has two phases, pre-training and fine-tuning. Pre-training is computationally and time-intensive. It is, however, independent of the task it finally does. So the same a pre-trained model can be used for a lot of tasks. In essence, GPT is not that different from BERT, and it is a stacked transformers decoder model. And there are many variants of BERT out there, including natural language models created by Microsoft. Here we see the BERT for question answering, and it was leading the superglue competition at one point in time. And we have PubMed BERT, which we can use to parse articles, scientific biomedical articles in PubMed to do named entity recognition more precisely. Right, so now let's take a look at another NLP problem of text summarization. Text summarizers are able to take the most important information from the source document and produce a reader-friendly summary. There are two types of summarization techniques in NLP: extractive and abstractive summarizations. Let's take a closer look at them. So what do we mean by extractive summarization? Extractive summarization tries to locate key sentences in an unstructured text document. These sentences collectively convey the main idea of the document. It is available within the Azure Cognitive APIs for text analytics. Abstractive summarization, on the other hand, is trickier and tries to generate new sentences that summarize a given text. Currently, it's not part of Cognitive APIs, but now there are large NLP models that can do this, including the GPT-3 model embedded within Azure AI. And we can also create our custom solutions as well. Microsoft introduced Turing NLG in early 2020. At that time, it held the distinction of being the largest model ever published, with 17 billion parameters. TNLG can generate words to complete open-ended textual tasks and unfinished sentences. The model can generate direct answers to questions and summarize documents in abstractive manner. It's not currently available publicly, but the idea is that it will be embedded across different cognitive APIs to improve the performance of our text-related cognitive APIs. And finally, GPT-3. It's both awesome and scary at the same time. In July last year, OpenAI released GPT-3, an autoregressive language model trained on public datasets with 500 billion tokens and 175 billion parameters, at least 10 times bigger than previous non-sparse language models. To put things into perspective, its predecessor, GPT-2, was trained on just 1.5 billion parameters. GPT-3 is applied without fine-tuning or model customization. It achieves strong performance on NLP datasets across different problems and can perform tasks such as translation, question answering, reasoning, and even 3-digit arithmetic operations. Mind you, this is just an NLP model, not a calculator, not a computer, and it can still do 3-digit arithmetic operations. GPT-3 was covered extensively in the media across different applications, including a Guardian paper. So this is an article titled "A Robot Wrote This Entire Article. Are You Scared Yet, Human?" You can search for it if you want to read it. So Guardian, I think, gave GPT-3 the first 2-3 sentences, and GPT-3 was asked to complete the article. I think it has done a very good job, and here in the footnote it says that there was some editing done. They changed the order of the paragraphs, but they didn't do any extensive editing more than what they normally do when people submit such opinion articles to Guardian. A short film of approximately 4 minutes, Solicitors, was written by
Present to you, Solicitors.
Another example is a bot powered by GPT-3 that was found to be interacting with people in a Reddit thread. It responded to some suicidal notes. Although no harm has been done, this incident raised concerns for OpenAI GPT-3 and its potential misuse. There is always the danger that GPT-3 and other LLMs or large language models may be used in non-responsible ways without the necessary safeguards. So what to do? OpenAI licensed the software GPT-3 exclusively to Microsoft. Microsoft has been already working to integrate Turing and GPT-3 into Azure services by following and imposing responsible use with additional filters and guidelines. Also by initially making sure the service is invitation only. And this was done to gauge and improve how these measures are working before a full public rollout. In the meantime, Microsoft announced that it created a larger NLP model than GPT-3 together with NVIDIA. They called it Megatron Turing NLG 530B. It's a 530 billion parameter generative language model which generated high accuracies in a broad set of natural language tasks such as completion prediction, reading comprehension, common sense reasoning, natural language inferences, and word salad disambiguation. This is a 105-layer transformer-based model, and here are a few of the accuracies obtained in the NLP tests applied. Now let's take a look at a few examples on how organizations, businesses are using these very large language models. GPT-3 accelerates human creativity with ideas generated near instantaneously. For businesses, this means more effective product descriptions, ads, headlines, and faster, more effective customer correspondence. For example, Microsoft's Dynamic 365 marketing platform aims to reduce the time it takes for customers to write effective marketing content. The app uses GPT-3 combined with past context for producing tailored results to help users publish effective content quickly. GPT-3 is adept at understanding nuances in text, extracting meaning, and summarizing information in the right tone for the right audience. This helps companies like Zebrium, who are helping businesses troubleshoot problems faster. Their solution parses logs, correlates anomalies, recognizes patterns to find the root cause. It then uses GPT-3 to summarize the root cause reports in plain English to help stakeholders make decisions quickly. So all the way from technical logs to executive summaries about the nature of the problem. Another example is Ross Intelligence, which offers a legal research platform that uses GPT-3 to better search through legal texts so that legal professionals can provide sound and timely advice to their clients. And the use cases are going to increase. Sapling, for instance, is building software products that help enterprises deliver a better customer experience for their customers. So this is a summary of the what the service offers. It offers 4 base GPT-3 models called Davinci, Curie, Babbage, and Ada, with different levels of capability suitable for different tasks. In addition to these 4 models, there is also a Codex line of models. The Codex series is a set of models that can understand and generate code, translating natural language to code and code to language. Davinci is the most capable model and can perform any task that the other models can, and often with less instruction. For applications requiring a lot more understanding of the content, like summarization for a specific audience and creative content generation, Davinci produces the best results, and it is the most expensive to use. On the other end of the spectrum is Ada, with the fastest of the GPT-3 models, and can perform tasks like parsing text, address correction, and tasks that don't require too much nuance. This service makes it easy to experiment with these models and find the right balance between capability and latency performance for your use case. Now let's talk about OpenAI Codex. The Codex models are descendants of the base GPT-3 models and are trained on billions of lines of source code, programming code, in public GitHub repositories to produce working code from natural language, which means that you can issue commands in English to any piece of software with an API. Codex models are the most capable in Python and proficient in over a dozen languages, including JavaScript, Go, Ruby, and SQL. Davinci Codex is the most capable, like its parent language model, particularly at natural language to code generation, while Cushman Codex is faster and more suited for real-time applications such as writing code in VS Code. To see just how easily Codex can make unfamiliar libraries accessible to everyone, let us perform a demo. We are now in Visual Studio, and the plan is to test two different languages, Bash script and Python. Let's start with Bash, Linux Bash. So let's assume that I'm not familiar with the AZ CLI, the Azure client, and let's say that I want to create a storage account. But before we create a storage account, perhaps we want to create a resource group. So for that, I'm going to say that create a resource group using the AZ CLI. So I just give it a simple hint, AZ, and then it does the rest. It works. So if I say that create a resource group with the name of my RAS, let's see, I'll delete this and let's try it again. Yes, it changed my resource group to my RAS, and the syntax looks good. Amazing stuff. So using AZ CLI, create a new machine learning workspace, let's say, instead of a storage account, machine learning workspace with the name of my ML. It's even predicting my line of thinking, but I'll ignore that for now. So AZ, yep, within the same resource group that is created in the previous. Amazing. That's really good. Now let's switch to Python. Let's start from something very basic. A function that does, let's say, multiplication. A function that multiplies two numbers. Yeah, it's predicting my comment as well. So def multiply, yep, I accept the suggestion. So this time let's do something a bit more complex. A function that does binary search. A function that does binary. So def binary search, yes, array, and we are searching a target within that array. Is it going to do any complete? Yes, auto completed the entire function. Unbelievable. And I bet it works, but we can always test it, right? So now I'm going to do something else, a bit more difficult. I'm not going to write any commands. I just pretend I'm writing a function that finds prime numbers, or checks whether a given number is a prime number or not. And let's see how it's going to help me. Yes, it's prime n. Yes, I want n to be checked. And then, okay, it's it understood my intention even without me writing down the task in natural language. So it's really amazing stuff. I'd like to finish by a quote from Noam Chomsky, who is a very respected linguist, philosopher, political activist, cognitive scientist of our time. He said in 2012 that the new AI focused on using statistical learning techniques to better mine and predict data is unlikely to yield general principles about the nature of intelligent beings or about cognition. It may be so, but I think we are getting closer and closer. And at least the new AI can certainly help us perform better with certain tasks. It's an exciting time for the NLP field itself, and also for us to try these new cutting-edge NLP techniques, models, and develop mind-blowing applications with them. Of course, all done responsibly. Thank you for watching, listening, and please take a look at the description for a few more links, references that I used during the talk.